Thank you for staying for the last session of the evening and of the first H2O World on the Paul Erdos stage. Erdos is quite interesting for our space because he's one of the few mathematicians that actually believed in collaboration and made that possible. And I mean, social networking before social networking was even there, of the kind that we know today. So it's kind of an honor to be on the stage and with the assembly of one of the greatest data scientists I know. So it'll be fun to have a very rich conversation today. I'll start with actually introducing different people in the order in which they have actually touched H2O. Chris joined us. Like probably the first time I met him was 15th of January 2012. Months before I had a name for the company. So, he had this distinctive curve, AUC over training time. And that's the curve we managed to achieve with our product. So Chris has practiced data science at Google, Netflix, and most recently at Lyft. So welcome, Chris, to the stage. Thanks. Then I introduce Lou Carvalheira has basically been, you've heard him talk this afternoon at the predictive modeling factory, but has an illustrious career, mathematician, and has done lots of interesting stuff before touching H2O from the open source, and leads data science for customer intelligence team at Cisco. So, welcome, Lou. Next, Vinod Iyengar. You heard him speak yesterday and briefly, and he's basically a marketing algorithmicist again, and has used their product at Rushcard, where he was before, and is now at Active Hours, co-founder of Active Hours, doing interesting data science work. I call him the social networking ninja. He's done a lot of really cool stuff doing social marketing, and so welcome, Vinod. Thank you. Next up is Nachum, who's going to create some real good fireworks, I think, today on stage. But Nachum is from, he's head of data fireworks. I'm kind of hoping some controversy today. It'll be fun. Okay. But Nachum is head of data sciences at PayPal. He's looked at our product over the last 2 years, almost to the date. Remember Cliff and I parking our car, hurriedly trying to go meet Nachum. I actually do remember, I think I got a ticket because we were late, but just in time. We go in and he says, you guys have good advisors. Come back when you have a product, right? So we went back and fortunately he obliged and we worked hard to win his trust. So thanks, Nachum. And of course, he's done, you've heard him speak earlier, so he's no stranger to the stage here. Welcome. Next up is Simon. Simon Zhang he leads BI and data science work at LinkedIn, another prestigious place for data science. They've literally made a good name, both Netflix and LinkedIn have been the front runners in the space, defining what data science is to some extent. But Simon has a very interesting background. He's done lots of really different things before doing data science and marketing algorithms. And he's a huge, he's a student of history of China as well. And he brings, so one of the things we'll talk about is his favorite data scientist is not even in the recent centuries, right? His favorite data scientist is a couple of centuries old. It's a very, like thousands of years ago. And so we'll come to the topic when we actually get to that. But welcome, Simon, and thank you for being here. And last but not least, Prasanta. Prasanta is really well regarded in the data science circles, Prasanta Behera. He's actually VP of engineering at Share This. So it kind of gives you an idea how data science is progressing from being just data science to data engineering and technology. This is happening with the space, but Prasanta he found our product from word of mouth I think, and about a year earlier this year, and since then he's tempered his judgment carefully, and now we're close to getting into production there. So, welcome, Prasanta. So it's a practical data science, and we're just following what was, I saw the big video that Arno put up about pit stop for competitive cars in the 50s. So I'll start with actually a question that is got to happen right after a competitive data science panel, which is Kaggle actually data science? Question probably posed to Nachum to start with. Do you consider Kaggle contests as data science?
Of course. Do I? I don't know. I mean, it's part of data science. To me, data science is, most seriously, is the whole process from going and trying to fetch the data and delivering, trying from a very high-level problem, you know, identifying everything, you know, that I said today and everybody remembers from my talk. And Kaggle, I think, focused, at least, I don't follow them that closely, but they focused on the training of the model, basically. Give you a data set, cool, you have a data set, you know exactly what every column means, go and fit the best model into it, which is a central part in data science. But is this the whole data science? This is someone maybe for some philosophers to answer that, you know. But they're a lot of fun, I believe. And why not? And the other one is, why does it matter if they're data science or not?
One way to think about it, I mean, I was going to bring up Netflix, right? The Netflix recommendation prize, the winners of Netflix recommendation prize were never actually implemented, apparently, or that's the meme. I don't know if it's real. It's an urban myth that the Netflix recommendation prize winner never actually was deployed in production. Is that something? Is it true, or is it?
I mean, not the entire thing, but parts of it. So they weren't gonna, I guess one problem with the Netflix prize is it didn't have any kind of like SLA or spec on like how long does it take to train, what is like how long does it take to score like a new person, So having an ensemble of 100 different algorithms that take forever to train and maybe a long time to score is not that feasible in real life. So maybe I agree with what he said, which was, Kaggle is only one part of it. The beginning is like getting the data. The data is in logs, it's in the database, and you have to get the data, and it's messy, and you have to clean it, right? And then the other part on the other end is then productionizing it, right? Like, all right, we get to do it at scale. We have to score within a certain, millisecond SLA or something like that. So it's a core, but it might be the middle, but it's missing the two ends.
I like to think of Kaggle as, or rephrase the question as, is Formula One a means of transportation? Yes, yeah, I think we can transport someone from around. But anyway, if you think more about it, right? I mean, it's because of competitions like Formula One that we have. Cars that we drive today, right? I mean, the technology that we have today, right? And plenty of the development that we see in these high-level competitions, eventually, trickle down to us, right? I'm very, very concerned with being able to do things in a short period of time. For me, production is a different type of animal, but clearly, I see the benefits of evolving. Science, with those types of things, and I'm very curious to see how Jose can beat everybody all the time. I hate him, but I think it's clearly science, right? But I'm a little concerned with very synthetic type of problems, and I'm very concerned with the fact that. Feature engineering is such an important part. That's what I think most of the times. How can we extract more from the domain? Right? I mean, understanding the domain. So I don't like the synthetic stuff so much, but I do like to have a car today that drives so well and brakes so quickly and is economical? So the answer is, I think, yes to the question.
Good, very good analogy. Simon, or any other takers? I could go to the next question.
So data science, LinkedIn and work with Netflix and a little bit with Facebook several years ago, not invent, but bring this data science keyword to the market, I call it, quote unquote market. My strong belief is science is like a seed, and it should provide a lot of leverage for mass amount of people and create value. That's my very basic and very preliminary understanding. However, on the other side, 100% agree with feature generation, preparing data, clean up the data, build a data pipeline. A lot of non-sexy work, work actually is the foundation for providing huge leverage by, introduce the data science keyword and to the whole world. I'm a strong believer about, foundation, build a strong and valid foundation, and finally, providing a mass amount of scale. And it's kind like what Shui built, right? The H2O platform, super fast, super easy, super scalable, and I believe a science should do things like that. Impact a lot of people's life in a positive way. Yeah. Thanks.
Thank you.
I might have like a follow-up question for the panel, I guess. Yeah. It's like, for the people who are hiring managers, you look at a resume and you see that the person has, top 5% in some Kaggle competitions. How much weight do you put on that part of the resume, or do you,
Yeah, I was about to say that I think it's great that we are living in a Kaggle, in a world where Kaggle exists, because when I was in school, there was a paucity of good data sets. So I had to learn a lot of things when I started my first job. Whereas someone who's coming in today has the opportunity to try out all their skills, try out different algorithms on these data sets. So it gives a huge amount of learning, and everyone is better for it. The companies who hire them already know that this person is someone who's actually worked on data sets. He's not just learned the algorithms theoretically, and you're able to apply it on big data sets. There are a lot of really huge data sets available publicly. And I think it's great that that's available, and it makes it, for me, it is science. It is part of data science. You learn a lot of it. And of course, all the feature engineering, all the unsexy parts, as Simon mentioned, you do learn those when you get to work in companies, but at least you learn the theory well with Kaggle.
Hello, can you hear me? Oh, okay. So the question was, how much emphasis do you give on Kaggle and other? So luckily, Gauchang, who was in the panel before I hired him, at least I can have one credit for that one. So generally, these are important factors, the Kaggle and the winning prizes, but every problem is different. So what I'll really focus on when I hire is, what is the approach the person is taking when so first one of the examples is say, hey, if I'm interviewing somebody and if I give a problem, they immediately, let's say, if they jump into, I got to model this one, this algorithm, that algorithm, then I know the person hasn't thought about what we are trying to solve, right? So I put more emphasis on how the person is approaching the problem rather than winning one prize. That's a good thing, it's a positive thing, but not solely hired because he or she won the prize or something. So that's my point.
I want to add one more thing to this. Part of data science that I consider important is communication. When you go to Kaggle, the definition of what you are going to deliver is given to you, fit it the best, etc. But when you talk to business people and they talk with you, because at least from my point of view, the models I create are consumed by business people, okay? And so they speak a different language. I have to show the output of the model and tell them why this matters to them. Even more important, what they would do with the results. And so the communication, and also when they dictate their needs, you have to understand, and then to translate to data and model and, and cleansing and whatever, and what will be the quality. The point is very simple. That is, you give them at the end of your modeling, you give them information. A simple question, what are they going to do with that information?
what you do with the analysis that matters.
Right.
But that actually brings back the other question we had on the topic, and I want to give it to probably Prasanta, is how important are KPIs and letting the business understand what you've analyzed?
Oh, it's super important, and I think I echo his feeling, because ultimately we all are trying to solve a problem, and before we solve a problem, we need to be very clear about how do we make sure it's a success, right? And I come from advertising, so okay, conversion or click through, whatever KPIs are the success factor, right? And so it's very important to know what our success factor is and how I'm going to measure it. What are the challenges of measurement, those factors? You have to know this before you start building your models, right? Just like you want to spend time on understanding your data, you want the same amount of time, you want to focus on making sure you understand the problem clearly, the business out goal, what we are trying to achieve. Then only I think you should proceed. Otherwise, you'll be building something which will not satisfy either way, and the business owner will say, okay, what did you give me? So that's the challenge. I completely agree.
I'd say, and I've been a consultant for so long that I don't know how to give any other answer than, well, it depends. Right? And I hate those answers, and I hate that I'm using it now. I'm not sure. I think there are problems and problems, right? And different problems require different types of knowledge and so on. I was the one that's saying 2 minutes ago that what I don't like about certain Kaggle, problems is that you don't see the features, right? I mean, you just have the columns. You don't see the features. You don't understand that. Right? You don't have the column names. It's pretty. I don't like it so much. So to emphasize the point that understanding domain, understanding the business, understanding what's being recognized by models, and putting that in the context of the activities and initiatives that will follow is pretty important. But I submit to you, I mean, if you have, I don't know, a model that tells you precisely, who's going to develop cancer of such and such, type, and it's a beautiful, very, very accurate model. Do you really have to be concerned with interpreting and so on? The model just predicts, well, give me that model. I want it. You don't need to explain it to me. I just want to use it. So there's, situations and situations, but to your point, Netflix, at a certain point said, I want to improve on that recommendation method. So, but there was other objectives. So again, different problems may simply need sheer accuracy of prediction, right? And others, we want to be able to interpret. We want to be able to do something about it in the context of what the models are predicting or estimating.
So there are two aspects. One is the model accuracy, which is a different problem than what we call the business objective, or making sure that what we are building is meeting the business objective, right? One is ultimately model accuracy. You'll run into build new models, different accuracy. That process continue on, but during the process, you want to make sure that whatever we are building as an engineer, as a scientist, is solving one business problem, making sure we're making money out of that. That's my goal.
Right, I think I have to say, accuracy doesn't always win. It's like, say there's a model and the AUC is like 0.8, and the data scientist can be like, oh, I can get to 0.85, it's gonna take me a year to get there, right? And you have to ask yourself, what is the incremental return on investment of bringing that AUC from 0.8 to 0.85, right? And maybe it's like $2, and you're like, okay, it's only gonna net me like $2 in profit more. It's like, don't bother, right? And if you say it's going to net the company like $10 million, you'd be like, yeah, go for it. I'll give you a couple extra people to work on the project in order to get it better, right? So look, keeping it and framing it with the business and the ROI and the incremental ROI of improving it even more I think is really critical.
And there is a one-liner in statistics model. It says, yes, it's statistically significant, but is it business significant?
Yes, right. Right, exactly.
Right. It's a great way to talk about it.
Mm-hmm. Does it matter?
Yeah.
Does it matter? So talking about does it matter, I don't know how much you can talk about it, but there's a lot of different problems you guys have solved in the last many years in your career. What were the ones that you thought you spent the least amount of time and got the maximum output? Like what kind of data science algorithms / data science problems? I mean, we had the similar question for the Kaggle contest. What was the simplest trick that made you win? What was the simplest of algorithms in terms of heavy lifting that gave you the maximum bang for the buck?
So I can start. When we're doing this, CRD is a startup, so as we are building the teams, normally a resource constraint, right? So first problem we want to tackle is the CTR problem. So we're a little bit seeing whether we can build a model pipeline, all this. So what we did, let's just do a quick, simple aggregation model, aggregate on under different axes, like the placement, the categories, and all these things. Take 5 or 6 features, and just build a model, quick model with R, and then put it together. The first thing I want to do is make sure we get some online data, because whatever the backend testing we do is great, but until we verify in the online world and make sure that it's affecting my campaigns or how it's improving, it doesn't meet my standards. So that's why that was the quickest way. And then even with the simplest model, we used to be able to get to a decent point where now, let's say our CTR was hanging like 0.01, 0.02. Now we moved to 0.09 by just doing the simple trick. Now moving to the next level was we had to build a model, but this was the quickest. And we did it in like less than 3 months from starting to production.
So one example, I highlight, or I call the point here. I think that the most or the simplest chart, we created at LinkedIn only take us maybe 2 days. Very, very simple. It's about a company's talent flow. How many people they hire from which companies? Let's say for this, let's say for LinkedIn, and how many people left LinkedIn and joined another companies. So that's a very simple chart. Extremely simple and straightforward. Only one chart. I believe that chart, or like only we talk about KPI. I don't think even that it is a KPI. It's nothing almost, right? It's just a chart. But that chart brings massive amount of value for LinkedIn, because when salespeople, let's say, use that, the information, chat with our potential leads, from HR, from recruiting team, they just not desperate, but they really want to have it, with them. That's help LinkedIn grow sales, quite significantly, quickly. So I would say the simplest part, most likely generate a lot of value. That we constantly see this, from different areas, including models, right? A lot of scientists might like to build a social network, super GPU-driven models on the back end. However, we found out maybe still logistic regression can give us enough lift and then quickly. So that's just my basic understanding. Yeah.
There was a rumor, I don't know how true it is, about the value, which is an e-commerce company, and I don't know how to name, wanted to have a recommendation. They are like in household stuff, and they didn't have any data science, so they decided to have the very simple recommendation. Everyone they recommended buy bed sheets. And then they hired data scientists to build recommendations. It took them about 2 years to get higher lift than that. So the point I'm trying to make here is that you have to look at what is the impact of the model more than the complexity of the model. If the impact is there, and it goes 2 ways. On one way, you start with a simple model, and you get the attention of the people, actually the consumer of that. Say, okay, I see the value. Okay, let's go on the next iteration and next iteration. And this is the way, I believe, to go and develop rather than take the, 6 years, whatever was there in Netflix. I don't know, it's not their employees, but to take this in order to deliver the ultimate, it may be not that useful because they didn't consider some aspect.
One of the benefits of working in a small company is that often the first model you build is there was no data science prior to that on that particular problem. And And one of the examples which we had is for attrition analysis. This is my previous company where we weren't really doing any good churn analysis. So all we were doing is when someone would call in to say that I want to cancel the card, we would then try to go after them and then pick it. And we built a very basic GLM model just to predict 30 days prior likelihood of someone leaving the product. And it was very quickly done. We literally a month, and because again it's a small company, very quickly tested the model, like trained it, built it, and put it in production. Immediately saw a huge improvement. And as I said, it's a great way to introduce, and everyone. Then we brought the culture of whenever you have a question, don't try to come up with an intuitive answer. Like let us take a shot, and then we'll test against your intuition, and then see which works better. And that was a bigger win for us, is bringing the culture of, whenever you can take a shot, let us take a shot at it, and then, we can still go with your plan, but let us at least try.
What and I have, someone that works with us, and my boss actually always says, always try the simplest things, right? And the simplest solutions for any problem, right? Because it's hard to beat reasonable, simple solutions for things, right? And if you're doing time series, try exponential smoothing, right? I mean, what is it that you have as the very basic stuff, right? And try to beat it after that. So always try the very simple thing that you can get, establish that baseline. But if I think back about what we have today, and it's probably not the simplest thing that we ever did, but that step from having an artisanal shop to create predictive models, we would do one, and spend days and days, and then do another one with different products and so on. That step of saying, wait a second, let's just do a massive data preparation, and let's make sure that our data is put up in such a way that would allow plenty of different models to be built, based on the same data, right? Just choosing different response variables to new target variables, right? So make all the predictors available for slightly different target variables, and loop. That was, a simple idea, very very simple. Plenty of benefits from that point on. From a business perspective, I think one of the greatest benefits that you can have from a very simple way of explaining things, and that's a very hard problem, I guess, in our business, right? And explaining what the hell is a model, and what is this probability that you're calculating, and how did we manage to do it to someone in business that doesn't have the background and so on. The simplest or the best buck that I ever had, that I've ever made with a simple thing is, forget about trying to understand what I'm providing to you. Just prioritize. Just use this as a ranking. Just use this as the guidance that you need to prioritize your efforts, right? Don't worry about the models, just use this. See if it happens, if it helps, right? So very simple things, and people get really, really stuck on, I want to understand, how come you're doing this, it's almost like a little bit of magic, if you're outside of our fields, right, of our domain, some of the stuff that you do kind of seem, a little bit of a magic, thing. So get away from that. Oops, I'm still here. Get away from explaining things and just say, use this in a very simple way. Like prioritize, and try to,
just
use
ranking is.
Rank, just use this as a rank, visit this guy first, and if you have more time, visit the second guy, and if you have a little more time, call the third guy. Don't bother with the guy down there. Don't waste your time with that. It's as simple as that. Is it going to work? Well, try it. You're going to see that it's going to, work better than what you do today. As simple as that. Right?
Yeah, I'm definitely a believer. Simpler is better. And, it's something like with you have a new grad data scientist starting the team, and they're like, oh, I did this research on this really complicated algorithm, and I read all these papers that are like all these complicated algorithms, and I really want to go, do the complicated algorithms, and you have to like rein them in and say, oh, wait a second, start simple, find that first baseline, and then see if you can improve off the baseline, because the baseline's going to be super simple, right? And then and how hard is it to beat the baseline, sort of thing. So yeah, even simpler, not even like a model is like sometimes just like getting some data and building some simple rules or heuristics, right? We can say say we're trying to combat like credit card fraud. You could look at the data and say look at the distribution of the number of cards they try to add and get rejected or something like that. And they keep on, every time they reject, they try to add a new card. Look at the histogram and say, okay, I think if someone tried to add 10 different credit cards and they all failed, that they're probably a fraudster, right? You don't need to have any kind of super machine learning, rule for that. You just kind of okay, based upon some intuition and some data, I can probably build a fairly decent model. So again, understanding the business.
I guess common sense is not that common, right?
Yeah, right. But you should use common sense and intuition. I think there is a place for that, and that's why maybe sometimes the computer can't beat the human, right? Because that's hard to quantify or code, right? Yeah.
Speaking of computers and humans, how much of, and we had a fantastic talk earlier too about predictive modeling factory and automation, and how much of today's data science is what people call stone age of data science, a lot of manual stuff versus automated stuff. And how much of what you do in a day-to-day basis is considered well automated or automatable, and how much is it a lot of manual labor?
I think I'd like to start. And because I spoke about the factory, right, I don't want you to believe that we just press the button, right? And everything gets marvelously, produced at the end. It's number one, we understood the basic problem very well, right? Number two, we put the right triggers in place to not allow certain conditions or certain types of models to ever be published, right? So you establish minimum quality criteria that would prevent bad models to go forward in the factory line, right? In the product line. Third, every time we created a model and produced scores and estimates and so on, we would, at the moment of deployment, embed control groups that would allow us later on to figure out that, oops, this model is horrible, right? Therefore, let's stop, right? So as interesting as the idea of a P2P factory, right? And press the button, everything gets done. It's not at all like that, clearly, but you have to have all sorts of mechanisms in place to understand when you're doing, when the models are not appropriate, right? And I wouldn't do it for Kaggle type of competitions, right? You have to have something that is, constantly being asked. It all started, right? Just to be clear, can you create this model that predicts who's going to buy routers? Yes, let's do one. And then the next guy, can you predict models that will? Can you create models that will predict switches? Well, routers and switches are pretty comparable, right? We can keep doing it, and we don't try to solve with that type of artifact, right, which we're calling the factory, problems that are very different from those, right? So I don't like, and I hope I didn't leave you with that impression that the factory is press the button and everything gets done. I really don't think it's a good idea to have that automation to the point of you blindly trusting everything that is produced. That's why I don't trust as of today, I think, tools that are given to business people and say, use this thing here, and automatically models will just be generated and so on. There's plenty of traps, in data, all sorts of problems with bad collection of data that, would, anachronisms that, could be embedded in the, it could be a horror story, right? And you wouldn't know about it, right? You could be directing all the efforts of a company in the completely wrong direction, and you wouldn't know about it. Right? It's really, really dangerous, I think, and maybe I haven't seen good implementations or completely automated ways of doing it. But I hope I didn't leave you with the impression that the factory is something, oops, right? Not at all.
Yeah, I think there's like I can see two things that that it needs to be a human in the loop, and one is I think feature engineering or getting the right data, because if you don't have the right data in your data set, you're not going to be able to come up with the right answer. And then two, I think is are you the problem that you're trying to solve? Are are you solving the right problem for the business, right? So at Lyft, the question is, what is our objective function, right? Are we trying to maximize rides, revenue, profit, driver earnings? So each of those will give us a different outcomes, and you have to make sure that whatever algorithm problem you're trying to solve actually solves the business problem, right?
So what you're saying is that we will have a job in the next few months, though, maybe?
Yeah, at least a few months, yeah.
Good. I like that option better.
I can add to that a little bit. So one of the challenges I have is we build models and then we say we push it to production, right? And then we score models every day. Some models are scored every day, some are scored more frequently. So one of the challenges is sometimes the score changes and it directly impacts the business objective. And for us, it's more campaigns and objective, right? So how do I build tools to make sure that a 0.03 to 0.04 is going to cause that kind of impact, right? So building sort of tools to make sure that the models and the scores, I can track it and make sure that if there is an impact, negative impact, I can push the, backtrack the whole model. That whole life cycle is a lot more complicated than, and so building model is just like, I think like 20% of the effort. The whole system of building, putting into production, making sure it's measurable, making sure we are quantifying it, making sure we are able to backtrace this particular thing change which caused this issue is a whole another set of problems, challenges.
So basically, I agree with what you said, and to basically summarize it, the answer is yes. You can automate the creation of a model, can automate it, no problem whatsoever, but I believe you need a human to pass judgment of the model. Is it even relevant? And a very simple example is you have an Excel spreadsheet, you can run linear regression with one button. Does it make sense? Or do you have one outlier that drags the whole slope? And then you can go use on the linear regression, try and go and present who knows what about the ROI, of if you just change this value to that value and you increase. So, because you don't know what effect, is the model even, does it matter? And this, I don't think that today we have anything that can pass judgment on this that is not human.
Yeah, so for the future generation, I just have one, quick comments. In the early stage, must be 100% manual because of LinkedIn is built from scratch, right? I think this one is a very interesting question because of it's almost attached to life, so because I know Sui is a big believer for philosophy, so not just data science, but also, philosophy, art, and music. So my feeling is, so data science is almost like life. When it started from, it started from very disorganized. When we keep evolving, so become more and more organized, and finally become extremely automated. However, I know, right now, like what you said, so it's almost impossible to automate anything, right? That means that we have a huge room to grow. From here, either to the true goal, to the true north. My overall feeling is, so at LinkedIn, at least, so we start with a purely manual build models, painful weeks, maybe a month, to put together all the features, and together. Right now, I think we set up a feature pool, kind of automatically collect all the data changes on the site. We have about, I think, so we synthesize, for about 100,000, field on the back end, and then we run model almost on top of the 8,000 or 10,000-ish, the key variables, and then we build a model, not 100% automatic, but very close to relative automation. That's create a lot of incremental impact because of before we only prepare data, even did not deliver any model or scores. So that's just 2 cents. Okay.
Thanks, Trey.
Can I pose a question to the panel? Whatever happened to the uncertainty around the results of the model? Usually in statistics, you used to have, standard error around. So you know that every result that you get has some kind of area of uncertainty. In data science models, we use a lot of coin flipping, known as sampling, a lot of randomness in the generation of the model, but I don't recall when was the last time I saw results coming with standard error around the results. You give to business a number, this is the number. And today, Trevor Hasty said, oh, just recently someone came up with a way to do standard error around random forest, but one is not still there for GBM. I'm kind of surprised. I mean, you take something that is generated purely by chance and you don't even say, what are the probability that it's not true? Any comment on that? I mean, when we will see some level of uncertainty. And just to make it more complicated, if you have hard time delivering model results now to business, try to deliver them with uncertainty.
I think uncertainty is certainly one of the problems, but more importantly, interpretability comes up more often. Like businesses really want interpretable results. And I mean, oftentimes, almost every one of my customers, including yourself, are like, well, where is the variable importance out of this GBM? And where is the kind of, how do I interpret it? What is the lift? Right? The first thing Lou asked us was, where is the lift? I want to see the lift out of this, not just AUC or ROC. So we see more of that conversations. Uncertainty is certainly not something that gets popped up on us even once in a long while.
I mean, I think a question is, like, a good question is, should someone care about the explainability of a model, or should they just care about the error, right? Is a black box model okay to give to the business? And you just tell them, hey, the error is really low, It's like, why do they want to know that, the factors that impact the model? So they get like a warm, fuzzy feeling, that they understand it. What's the value of that?
That's reasonably controversial.
Yeah, right.
That's reasonably controversial.
Right. So.
Do you really need to know why it's giving 99% accuracy that it's going to rain tomorrow?
In some sense, you do a little bit because, for example, data is not constant, right? What I like to, let's say I'm getting data from various sources and I'm building my model. I like to know is, okay, if this data pipe, something that I'm doing is going to close down, how much impact that will be? Let's say I'm buying data from some external sources. How much it is worth, right? So in some sense, indirectly you want to know something because the business guy says, okay, I'm going to say, hey, buy the data from this sources, it's going to cost you blah. I want to be able to some level of quantification to say there is some value to it and how much value to it for that.
Yeah, but the other thing is that, so regression is a study of correlation, and people want to infer causality from the results, right? So they're going to say, like, you're going to tell them, like, hey, if I wear a rain jacket, it's going to rain today, that's not causal, but they're going to interpret it as anything you tell them as causal.
So does big data make correlation? This is a common theme we hear sometimes. Same as causality, right? And how much of data science today is actually trying to tease out causality versus just taking correlation between two different things?
Well, as Lou was mentioning about how he saw an horoscope model. Yeah, but I mean, when you take like a black box model, that you can get results like that when completely nonsensical results. I mean, you throw in zillion variables, you might get some predictability, and you don't know what's causing it, and is it just pure random chance? And going back to Naum's point that if there is no standard dimension, people seem to think, okay, it's predicts, you might have just put in coin flips or whatever. So I think there is still, and going back to this point, is if you don't understand what are the variables or what are the features, what are the data points which are going in, when you're future test data, and if you're using real time, for example, if your future data differs or changes, your model is going to predict wrong results because you don't know what are the things which are causing the change. It probably doesn't answer your question directly, but I think it goes back to the point that it's important to know what's going in the model and what are the things which are affecting the results.
There's this whole idea of data blending that's coming up, which is basically what are the different data sets in my overall repertoire of data that I can pick to answer a big question. And oftentimes it's which data set you pick that makes sense. How are you kind of trying to navigate that space, where whether it's adding weather data or whether it's adding like different new data sets that are now available? How are you kind of, it's almost like an art form, which data to pick.
It's a little bit tough one also because you might find that this certain data works in certain cases. Like for example, from the ad side, you might say this data works for this particular campaign, auto campaign, but doesn't work very well for finance campaign. So quantifying each data element is really, really hard, at least for my the area that I work on. So right now, I think we don't have a great framework to evaluate, say, hey, if I get external data, how I can quantify it. You know, it's more like a lot more hand waving and some Excel to analyze and see. You know, I just do a little bit A/B testing. Is okay. I use data A and data B, and okay, I see around 5 campaigns, and I saw like 10% lift. That's pretty much level what I quantify it. Otherwise, element by element is just tough, at least for us.
Yeah, you also lose control sometimes when you buy data from third-party vendors. We used to buy a lot of credit scoring models from other vendors, and often you don't know what data goes into those external models. So you or vendors, all you get is a set of scores for a particular user. And if you depend too much on those, and if the model is completely dependent on those external data points, then you don't know if something changes on that end, you are left with a bad model, which could lead to a lot of losses, like in the short term at least, if not in the long term. But so I think it's important to know where the data is coming from before you you start using all the external data points. How reliable are those external data points? That's sort of the question.
Simon.
So I think this is a great question. Also, this question also connects with the previous question about the uncertainty, right? Uncertainty question. I think these two questions are exactly almost the same, So one thing is, it's the beautiful of our data science or data is when we have a lot of uncertainties, actually things become certain, right? So I always had this question, even after a lot of stats training, hey, why the world is distributed like a bell curve shape? That was my question for a lot of PhDs and statisticians before. They give me a lot of great answer by using, calculus, complex mathematical models. But after that, actually, I met a professor. The answer he gave me is very simple: random column A, random column B, random column C. When you sum, more and more random, let's say from 1 to 100, when you see the total, right? So those random numbers sum together, let's say column Z or column X. So it's the more columns we sum, the more normal distribution, or the shape it looks like, which means, when we have a certain data, so our multiple fields, so actually I can increase our likelihood to predict. So I don't know, how much they would help us. Even those random signal, if we use this in the right way, we could provide more leverage. That's what I see at LinkedIn, right? So I'm not saying the more data have, the more value, but the diversification of different type of data set definitely provide a lot of cross leverage, for different business lines. So.
In our business, we use plenty of data from external providers, right? Funny things, some of the products that we sell could be. I'll give you an example, right? Wireless, these antennas and these wireless routers that you see everywhere. They are, you can correlate this with the size of sites, right? I mean, how large this building is could give you a hint of indication of how hard it is to pass, cables all over the place, and therefore the higher or lower likelihood of you needing a simpler solution like wireless, simpler in the sense of not having to pass cables, right? So, do we have any source of data from in any way that give us square footage of buildings, right? It's kind of funny. Why would you need that? Right? But there's some models depend on that. So we do have providers that have all sorts of crazy, lunatic pieces of information that you really wonder how they get it, right? What I have to say is that in the past, we figured out that they were themselves creating models to provide this information. So we were building models on top of models that were being built by other models that had models as the input for the other models, right? So we realized that there were, some problems, and we had this ensemble of models. It's just that we didn't know about them. That's probably where the idea came from. So what we decided to do, after realizing that those things were happening was, okay, can we establish for that particular, important piece of information or variable and so on, can we at least understand when it's a model, when it's actual value, when it's, there's some sort of a reliability or confidence in that particular value. And we abandoned plenty of the data that was coming from these providers, and we started building our own models on top of just the subset of information that they said, well, this was we collected. In other words, we were replacing the models that they were doing themselves. But at least I felt confident that we understood at least the pitfalls and the confidence that we could have with that. Right? I got hold of the problem. I probably not much better than their models, but at least I understood my confidence, or which confidence I could have, and that happens all the time with us. I have to say, some providers of data and models do such a crappy job, right? I mean, you would be surprised at what sometimes you see in providers of models is really, really a shame sometimes. It's very easy to push bad models as a model. To your point, how do you know, right? It just takes someone that seems to know about the technology to convince someone in a business that this is a good, solid piece of work. Is really, really horrible. I've seen this many, many times in my previous life as consultant and so on. So it's really a shame. Sometimes, anyway, it's just a shame, right? What you see in the field as well. So,
I think with like third-party data, you want to generate like a hypothesis, right? So for Lyft, it's like, I bet like weather affects like the demand rate for Lyft. So when there's inclement weather, when it's snowing out, the demand for Lyft is going to go up because people don't want to drive. So that's just a hypothesis I have. I generate from like looking at the data and knowing that, hey, and it was snowing in Boston on Monday, and demand went way up, and it was abnormal. So I was like, okay, now I want to try to prove or disprove this hypothesis, right? So maybe at first I'll be like, well, instead of like buying a gigantic like 100-year history of the weather data set, across all the zip codes in the United States, I would try to get some free sample data, right? So maybe I would go to weather.com and see if I can download the last 30 days for free, right? And then it might not be all the cities that we operate in, it might be a subset, and then try to see is that correlated with the demand sort of thing. And if it is, it's like, oh wow, it's correlated. So that gives me more faith in order to buy the big giant data set, third-party data set, and to incorporate it. And then I can test that out in the full model to see if it still adds value.
Are you guys doing surge pricing as well, Lyft, or is not?
Yeah, we do. Oh, it's not called surge pricing. We do dynamic pricing called prime time, right? Mm-hmm.
And that incorporates some of these weather patterns, I would assume? Or
weather patterns would cause the mismatch between demand and supply and cause prime time.
Prime time,
right?
Yeah. Mm-hmm. What are you guys doing for missing elements in data? And we'll probably go just quickly on NAs, replacing NAs is what's the most effective one versus?
Let me first give some comments about your previous answer. It doesn't work? Yeah. It does work, okay. So let me first give you some comments about your previous answer about the data, and we talk about third-party data. If you own your data, I mean, and you generate and you create and go through multiple databases, there is one concept in data architects called lineage. You have in a table the data, where did it come from? Did it come from this? It was from this joint. So you know where they came from, and you can, at least theoretically, follow them to the source and to see how it was created by rolling dice or by maybe some measurement that can be relied on. All this, in my opinion, break down in a lot of third-party data. You just get, you have no idea where it came from. You have no idea whether they used, imputation. You don't know if you see value, where the value came from. And I have some other stories about how they actually collect the data, etc. So you have to do a lot of, how shall we say, checking on the data, and it's just a simple outliers here and there. There are all kind of phenomena that the data just does not represent what it's supposed to represent. And so this is why you have uncertainty in the data itself. And therefore, you need to understand that what you create as a very definite number in the model has uncertainty in itself. And then you ask, why should I care if 90% tomorrow will rain or not? Because one reason is because if I'm telling you tomorrow there is a 40% chance that it's going to rain with plus minus 60%, then as if I didn't tell you anything, you know? But if I cannot tell you a narrower range of uncertainty, then basically you just go and say, you know, what? I mean, just go and make up the numbers. And so this is part of the thing. It gives you the confidence. The other reason that you need to know if the cost of missing is higher than the cost, I mean, the cost of false alarm versus the cost of missing, because if you know that you have the range and you say, should I go out? It may rain, and then you get, you know, dissolved totally, you know, but which is not a very good thing. You want to prevent. So it depends how risk averse you are, and for this you need the range of uncertainty, the band. And now you ask about how you fill in, what you do with data that you don't have. Well, there are some interesting algorithm like random forest. You know, they work with that, no big deal. And you guys allows the data scientists to say, don't allow columns with more than so many percentage of that. And then there are plenty of ways. If you want to fill in those things with mutual information, with average, with whatever, you can do it, but at least make it known that this is how it was created.
I was thinking for like first-party data, it's an engineering problem, right? You know, if you're creating the data and you have missing data, then you have an instrumentation problem, and you should go fix it, right? And that's the best way to mess with it. Yeah.
Don't impute, go fix it at the source.
Yeah, right. Exactly.
That's a good idea. How much of this missing and this sparse? And some of you guys deal with really sparse data. So what are you doing with sparse?
Yeah, so from our side, I think we run into a lot of instrumentation challenges. So there are two things we do. One is that in the data pipelines, we instrumented to measure, you know, how much certain data elements on the day by day, how we're getting it. So there is some threshold I've said, if it crosses that threshold, we get an alert or some, you know, the email to the engineering to say, hey, there's something wrong, we got to go fix it. And most of the time is like instrumentation. There are certain data that we rely on other side, like for example, a lot of these conversion pixels are on the advertiser side, right? And you find that these pixels are not firing because they change the pace, something down. So those are a little bit hard problems, and you have to go one by one and work through the whole business side to make sure they fix it. unfortunately. On the generally data, majority of the cases if we have a good system, in the first party data, we are in a good shape. We're not talking about 90%. There is always going to be some percentage of data missing or some minor instrumentation. As long as we get majority of data, we're fine. But if we are, and most of the cases that I found, if data is missing is because of some bad instrumentation or bad coding or something, which cause this. Majority case we find that, but there are always exceptional cases.
What are some of the most controversial aspects of data science? How much better is it than just random? Does random always almost beat modeling, or is it?
How much better than flipping a coin and making
Than flipping a coin, yes. Like people you may know, I can just flip a coin versus modeling. Is it real?
What I think is the difference, because if you flip a coin and you get a number and you act on the number and it doesn't work, you really have no idea what to do about it. And I would like to believe that if you have a model and it didn't work because of some reason, you can start argue how to correct your prediction in order to make it more effective.
That goes back to the interpretability question, right?
Yeah, it's a machine learning and human learning here, yeah.
It's more it's more measurable, right? Even if it's a black box, you can say like, I did cross-validation and my AUC was 0.85, and that's much better than the random coin flip, which is 0.5, right? So,
But chances of success.
yeah, right. So you can quantify, how much better you are, right? And so that's a good thing about being a scientist. Is like it's not just a gut feel like, oh, I think my algorithm's better because I did it. It's much more. I have data, and I can show you how much better my model is versus random chance.
Give me data.
I think the most controversial problem I have is really what comes first. If you think that the predictions you create and the models that you create, are essentially something you do to change the way the business, does, right? Operates. You hope to learn something that is of value, right? But in which way are we not simply learning what we have been doing forever, and we're just perpetuating this, never-ending cycle of, funny enough, we sell, college books to, people in between 18 and 25, right? And my models looked at historical data, and we have a pretty good prediction accuracy, and it has a lot to do with the age of the people that buy the books, and go there, try to sell to them, right? And funny enough, they do buy, right? Mm-hmm. And my model is just proven very successful, right? And maybe I get a promotion, but is this the right way? What can we? And I've constantly asked that question. Aren't we simply predicting?
Yeah,
right, absolutely. It's but be careful, because we have this data mining thing now with a lot of science and powerful mechanisms to find all of that. Trust me, we are selling college books to people between 18 and 25. We are. I can tell you. Go there, try to sell to them. So. I think we have to prevent that type of thing, right, by, again, putting random things, right, in place, right, just random. And this has nothing to do with the way we learn things, but it's the way we deploy, the way we apply the end result of our work, right? And I think that is quite And I kept thinking about this all the, at night. I say, am I really doing the right thing? And I hope I can. You're never completely sure unless you do these types of experiments and you make sure that is traceable. Right?
Simon has something
Yeah,
to say.
to echo the point you just mentioned, I feel, so to beat randomness, there's one thing I just really feel this strongly, is being creative, right? This is not just learn from data thing, it's just the data is here, how we can use this, right? So for example, people you may know, that's been generated at LinkedIn 7 years ago, right? I think Jonathan Goldman and the team, they did a fantastic work, No one asked them to build that model. They came that idea, automatically. And another example, we have this company flow information, and at one moment we never have some task. Hey, how can you use this data? For example, give you a task to rank order the companies across the whole globe, right? But we did something. We just follow some basic sense about it. People move to better place by only follow this basic rule. We start building some iteration on top of this data. Very simple, right? Which person come from which company go to another one. Finally, we have a rank order of some of the companies just for fun, and it's amazingly correlated with in the next 2 years the IPO chance. So by only using the people flow across different companies. And I remember we run that about 3.5 years ago, and we done some potential companies there, and some of the results were shocking. No one would imagine, let's say, Google is better than some super hot companies. Pre-IPO companies. Google was better in the ranking than some of the super hot IPO companies. However, after 2 years, the market proved the results are accurate. So, and then that's opened the gate for us to say, hey, how can we leverage this data better, right? So I would say being creative and not just learn from lessons or results, sometimes can unlock, a lot of more value than we could imagine. So that's just I would say to beat randomness, there's something not random, right? It's human being, this something is super creative, and our imagination, the power in imagination, and however, it's easy to say, very difficult to do. We really stuck in day-to-day.
How much of your day-to-day today is sampling?
We do a little bit. Some products we do use the complete data set. Some we do sample a little bit. So it's not like either one way or the other, right? Certain things we want to start testing ideas, we just sample quickly. But as we grow and as we understand better, I think we move to a full data set. So there are things like where you do raw data, where you do models based on complete raw data, or you can just use aggregate data and then build models out of it. So it depends, I think. I don't have any one particular solution.
Sampling is critical still, I would say.
It is to understand the problem. Because if you have his data initially just to understand the problem, some sampling, some randomness, it allows you to quickly develop something quickly. Because one of the things is, I got to this data, I have to build this pipeline, it's going to take 3 months and blah, blah, and then it's okay, or 9 months. So, okay, why don't you take a sample data, we just build a model and just force it to, my focus is always do the online testing, and that's the only way I see whether rubber meets the road, right? Let's just throw what the idea is, and then just go back and then iterate on it faster. That's the best way. And instead of waiting for 9 months to build the whole data pipeline and all this thing and then start building model.
R versus Python, and a similar question that we posed the other group. How much of is R more of a mature product with a lot of different usages? But we see a lot of the younger generation now going after Python. How are you facing that challenges? wherever you're practicing data science?
The guy that has spent his entire life working with SAS has no idea. But no, I would say that Python seems to be
actually SAS is, SAS, R, Python. There are three very
right. Well,
published.
Yeah, SAS. Okay, so I'll extend the question then. SAS is a very easy language to learn. It's very focused on one thing, and that's it. So it hasn't changed in the last 45 centuries, I guess. It's still the same. And clearly it's very, very focused on that particular objective, right? I mean, it's very restricted. It seems to me that if you do have a more statistical, related problem, R is clearly the answer. If you have to do more data preparation and so on, you will probably want to use Python. If you have something that you're developing that will require, Python is a more traditional programming language. You can do more with Python than what you can do with R. But clearly R offers tools that people like us, statisticians and mathematicians, value more, right? That being said, with all these scikits and so on, you're really in good shape if you're using any of these two languages. It can do pretty much everything that you need with these two languages. Did I say it right?
Yeah, definitely noticed a definite transition to Python from R. Maybe 5 years ago, everyone used R. Now everyone uses Python, and definitely I think it's maybe it's a younger generation, trend. And pretty much I think anything you can do in R, most of the time you can do it in Python. There'll be some library now, or.
Yeah, I agree with them. I mean, it's more and more. So many libraries are available in Python, and when I go to conferences, you find snippets of code. Pretty much everyone has their GitHub open, and in GitHub you have all that Python code. So it's very easy to, if you learn something, you pick it up and then try it and test it. So it becomes very easy to test on Python, at least in the last few years. Again, both are equal. You can do pretty much everything in R and Python, but wherever the resources are available, you make the most of it. So.
There is a difference between an individual data scientist, what you're going to use, versus an organization. If a data science company says, I want to work with SAS because I'm used to SAS, whatever works. Go work with SAS. If you deliver the results, go for it. So you have those, and I've seen and noticed and followed all the development in Python. And I think Python is superior to R in handling text. But Python is still not even close to all the 6,000 packages that R has in whatever you need to do there, etc. Although they're getting there. I mean, they have good examples, and they following up on that. So the bottom line is, if an analyst or data scientist want to use a particular language, go for it. I mean, most of them are free except for SAS. If you feel okay with that and you build your own. Now, if you get to a larger scale, like a team, you have to decide, should the team work on do you want to do it in Java or in Scala? And so, but if people claim there is one cliche, that R is not for production. If this is true and people believe that Python is for production, I believe some of the original code by some big companies was written in Python. So if Python is production-based, yeah, this is good, R is good for prototyping. What do you do for production? So there are all kind of arguments for and against. So it's definitely not the liking of the model. My personal, if you really want to go and very fast iteration over multiple algorithms, etc., I personally will go with R. Once you established, go and put it in a more traditional programming language. That basically is, and I also would like to add to this controversy that Emacs is by far superior to Vim. Okay?
Yeah, that's when for at Lyft, actually the back end of Lyft is in Python, and the data scientists are using Python. So it's actually nice that they're using the same language, and there's not this translation of like, hey, I use the SVM package in R, and now like and then hand it to the software engineer and say, oh, now you have to implement it in Python, and they'll have to like research how to do it. It's like they're talking the same language. So many times a data scientist can do the productionizing work because it's in the same framework, right?
In terms of productionizing, what are you typically using? I mean, most sophisticated models never get to production, and that's kind of probably the bottom line of the Kaggle versus practical data science. What is typical? I mean, is that pushing us to use just Bayesian/linear models or regression models? I mean, basically going to GLM. GLM is easy to productionize. What are you guys typically using for productionizing sophisticated models?
So productionizing means a whole lot of things, right? So one is once you build a model, how do you push it to, and then for us in the ad space, we have a real-time bidding system, so which sucks in the models. So one of the critical things is since all the real-time bidding, we have very limited time, so I need to decide on a bid within less than 30 milliseconds. So any model that we've chosen is make sure that the performance is good. That's one thing. Memory, I don't want to have a model. Sorry, if I'm supporting lots of models, how much memory is consumed. It's not too critical, but at least knowing those things makes me rational that hey, and the third thing is basically we make sure that tools are built that whatever the models are being generated, I could verify the verification systems that models generated and models in the serving system are the same. So we find, making sure all those little bit of last linkages, otherwise your results are different. We also make sure that whenever we log data on our bidder side, we exactly tell what model was used with the ID and all those things so that we can correlate if there is any issue on the serving side. So those are the things we use.
At LinkedIn, we almost not rewrite the whole R in Java, but we definitely rewrite a lot of key functions in Java and deploy it on the server side. And also, I believe we did develop several in-memory database technology. So before was SensiDB, and recently we just released a Qbert. So internal we call it Pinot, in-memory computation. So to leverage the function we write on top of the internal system and also server side plus offline side Hadoop system. My feeling is like exactly what you said. So R and Python is great, but not as extremely scalable. So, and there are a lot of overheads for us. After we prove the concept, we have to transform the language into a scalable solution. Actually, our engineering team, it takes a lot of time to restructure the function and the features. But my personal feeling is, how many companies would have luxury to rebuild all of this again and again and again? And for example, rewriting a logistic regression on top of a distributed system, that's cost a lot of brain power and manpower to do that. That's why I would say I'm a big believer for the water concept in S3, and his company is building, and hopefully you guys can help a lot of companies to scale that, right, in a great way.
Hopefully, yes. So if you had to pick between big data and better algorithms, what would be the choice to make?
Sorry, what?
More data versus sophisticated algorithms.
More data versus more efficient algorithms, more efficient tools, and so on. That's a hard one, but usually data trumps algorithms and any time, right? At least we used to think that, right? There are some problems that are impossible to solve even with the best of H2O's algorithms, right? So generally, more data is better. I'm not the one that says that. We had so many people saying that or have said that before me, but I don't think it's so easy to answer that question these days, right? Given that the algorithms have become so good. Sometimes with just enough data, you can do a lot, right? So it's not as simple as it used to be, right? But generally, data trumps tools and so on.
Do you have perspective on that?
I would say it depends.
Smile.
Maybe like better data, right?
Better data.
Not more data, but
Good
better
data.
But better, yeah, more higher quality data or more relevant data, right? That's like there's like a golden feature. Like if you had this one feature, you'd be able to predict perfectly. So if you get better data that had features that are closer to that golden feature, then you're going to do a lot better, right? So maybe you're not instrumenting the right things, right? Or maybe the stuff that you have instrumented, there's some noise in there. And if you can remove the noise, then you can have a much stronger signal.
So your answer is better features.
Better features, or better, that comes from better data, right? Mm-hmm.
In terms of surprising results, data scientists are apt to find a lot of surprising results in their lives. What was some of the most surprising, like really shocking results that came out of your analysis practically? The one thing that we did here, for example, the $1 transaction in USPS was a very surprising result for one of our customers. And they found out that that's actually far more interesting in predicting the next 3 months of purchases in credit cards. And the $1 turned out to be a change of address eventually. But anything that jumps out from your analysis?
I cannot think. I cannot think of anything, but I can tell you, because you started it. It's all your fault. You started it. A surprising result is not so much in the results, but it's probably the effort. A surprising effort is that I've seen someone using horoscope as, predictors for a model. I don't remember, this was like 8 years ago. That was quite surprising that someone would try that. I don't recall anything that, I found that was, wow, that is shocking, I guess. I'm too old for the shocking things.
What is the horoscope story?
The horoscope story was that I went to a conference, I think it was probably a little more than that, 8 or 9 years ago. And there was one panel, one person, who came with a model. He was trying to predict, some sort of sales or, one of those models that very correlated with, very associated with, who's going to buy something first. And he was doing it with horoscopes. In other words, he would collect the date and hour of birth of the customers and the place where the customers were born, and would establish, zodiac, I'm a Gemini with ascending whatever. I don't even know how to speak that language, with the ascending whatever in such and such thing. And he was pretty happy because the model was quite good. Maybe it was one of those models that, who's going to buy college books, right? So he was seeing those. But I thought it was fascinating. And it was by far the busiest, presentation. Everybody wanted to see that guy because everybody thought that he was a lunatic, right? But it was very entertaining, and it was that's the story. So you see plenty of things, I just give enough time, you will. That model, I think he has a chance. Yeah.
I think at Netflix, when a data scientist was doing a predictive model and was trying to predict like cancels, right? And it's like, wow, I looked at the calls to customer service, and it was like super predictive of cancels, right? AUC is like through the roof and greater than 0.9 something, and it's like, oh wow. And then, so this is maybe a lesson learned is like, well, then we think about it, it's like, well, you have to actually call to cancel, right? So when you have your target incorporated into one of the features, you're going to do really well.
I think, you know what, I think that every result that you generate has to be somewhat surprising, because if it's not surprising, it can be predicted, you don't need that result. I mean, you can argue what it is.
Well, the rule engine then, yeah, you don't need it.
Yeah, so it's, so unless, and also if it is surprising, you have to come up with, if you create this, you have to come up with, you have to be ready to meet resistance to it. Because it kind of shakes some people's beliefs and people's assumptions. So if it comes smoothly and they say, wow, this is great, how surprising it wasn't surprising.
Yeah. I guess that is the nature of, that is the structure of scientific revolutions anyway, right?
It reminds me of one, now that I racked my brains for a surprising result. So when we were doing going back to the iteration problem, one of the assumptions was that if someone has a lot of customer service issues, then they are likely to lapse or likely to stop using the product. And the way our call centers were managing that issue is that their traditional measures of FCR, CSAT, all those measures were being used as predictors for customer service issues. And we found that, on the other hand, so surprising is that lack of customer service interaction indicated that the customer had checked out in a way of the product. They had stopped using the product. They're not really canceled it, but they have slowly stopped using it. So it became less and less a part of their daily lifestyle, which was a better indicator of churn, eventual lapse, than anything else. So we sort of use that to like change our customer service interaction. We stopped using handle time as a measure. We said the call centers should not worry about handle times. Spend as much time as is required with the customer. You don't have to like try to get a call resolved in 5 minutes, for example.
That is actually quite common, right? I mean, we do see people that in customer satisfaction surveys and so on, the ones that complain the most are the ones that are invested in you, right? And funny enough, they complain, and they buy again. And that is probably a surprising result. But if you think about it, right, you kind of understand clearly, right? That is actually a common thing to do. You could actually, in the world of churn and so on, or predicting buying behavior and predicting purchases and so on, use that. How many complaints? This works pretty well in telcos, right? I mean, in telecommunication companies, phone business, cellular type of service, right? The ones that complain the most are the ones that still are giving you a chance, right? They stop.
We're coming to the tail end of the evening. Leave with a positive question here. So most of you come from quantitative backgrounds and have started doing math probably very early in lives and picked up data science as your piece. If I'm a young person today trying to be a data scientist or trying to, like, in the future, be a data scientist, what are some things that you would recommend starting off with?
Yeah, start with the math and statistics. Like all this other stuff can be learned, like SQL can be learned easily, programming languages can be learned easily. But if you don't know the underlying math and statistics, then you're not going to get that far.
Well, I'd say, competitions, subscribe to blogs, and listen to what people, are discussing. That's, how I found H2O to begin with, right? How I found about it. But a new person, I think there's no better way than, try this. You guys are excellent for that. Right? I mean, here's an example. Here's what you do it, and you have 4 times as many lines of comments in your code than you have good commands, right? So pretty nice. If you do want to learn, basic stuff or more sophisticated stuff. You know, you guys do an excellent job, and I have to give you that.
H2O is a good place to start learning.
Documentation, the code.
But you're right. You know, linear algebra is your friend, I guess, in general. And you know, to kind of follow you, but that's what I would say. You know, and knowing a good, you know, R or Python is probably the best way to start your career and understand how to manipulate data and so on. But you're right. I think you summarized it pretty well. I don't know how to add to that.
I agree with everything you guys said. In addition, I'd add that, you know, I think a curiosity to learn what's happening in the business, I think that's a very important skill for a data scientist who comes in. Data scientists are not mercenaries who can just come in and like solve, like throw a model at it and solve it. So it's sort of summarizing what we discussed all, or have, you know, spend more and more time with the business, understand the problems, and like, you know, respect their intuition and what they've learned over time, and use that as a guiding factor when you're building your models or when you're cleaning your data, doing whatever steps you're doing, and then eventually having the humility to understand that, you know, sometimes they know better than what you are doing. I think that approach will serve any new data scientist well.
So, again, I agree everything that was said. Math and stat are extremely important, probability. You need to understand what these numbers, even on your GUI, there are numbers if I'm not wrong. So you need to be feel very comfortable with that, and you said about the business. One thing that you need to be also passionate about data, because let's face it, data science is an extremely boring profession.
It's not sexy, it's boring.
Oh, of course. Extremely boring. I mean, unless you like to work with all of these data and everything, you go and try to figure out why this and not that happened, you know, sending bug reports and all. It's a lot of data grease under your fingernail. So
the sexiest.
I think the two things that done the most damage to data science was that statement that, by the way, it's not about the data, about the statistician is the sexiest profession. That was the original, and I would totally disregard that, remove from the record. And the second one was that that report that says that 1.5 million of those professions will be solely missing. So a lot of people are now going into a crash course of talk about Python, about like 6 weeks or 4 weeks, getting scikit-learn functions, and you're a data scientist. And so
I see a lot of Coursera
like, yeah,
Coursera,
data science course.
a lot of that stuff you can just go, but if you just expect to come and be a rock star, then wake up and smell the coffee or the cappuccino or whatever else you want to sell, because it has a lot of very long, if you're actually doing it yourself and working on the model throughout a lot of very, I won't say boring, but I did say boring, but I'll take it back a little bit, but it's a lot of work that is, you know, it's not glamorous.
You've had to challenge some algorithms, like not too long ago we were looking at is GBM doing something different.
Absolutely, you have that part. Of course you have that part, but you have to understand that to get to that part, you have to go and make the preparation to get to that part, and that is sometimes a lot of work. And if you sit there and say, give me the data and I'll give you the model, at least from my perspective, I'm not sure how this is going to work in the long term.
To echo that point, which is great, a lot of people think data scientist is a very sexy job. Actually, the dark side of the moon is very dark. A lot of hard work, I mean, behind the scene. Boring, tedious, 95% of work is preparing data, seriously. And 95% of work, communicating with business partners. 90% of work, redo, the other 90% of the work already been done. And I would say, the people want to become a data scientist, number one question maybe asked is the question behind the thing, what exactly, the people or potential we want to become. I believe all of these great data scientists sitting here, not including myself, I'm not a data scientist. I don't think I am. So I don't believe you guys want to be a data scientist 10 years ago. That would have been my guess. Because at that moment, this term might not be engineered yet. But as of today, as you get to deliver tremendous value for the company or for members, right, for customers, I would strongly recommend, suggest the professional want to become a data scientist, so look at what exactly the value we are creating for other people, right? But not just being a data scientist to get a fat paycheck. So fat. Oh, not thin maybe. So yeah.
Supply and demand economics, man.
Sure. Yeah.
So for I think definitely somebody who has strong math and statistics, and definitely curiosity is the most important. And I think I'd like to add is the pure data science. The old way there is just science group and there is engineering group, and you just handshake each other once in a while. That whole model is converging, right? Most of the data scientists are now kind of in some sense engineers, right? So understanding the engineering principles are also as important. It's just not about, and as I say, building a model is just 20% of the whole thing. So understanding the challenges, understanding what it takes to work with the engineering team too, and the challenges is as important.
I just want to say something. There's no boring data mining. There's only boring data miners.
So
I hope that is clear.
Really?
There's definitely boring miners.
Really?
Bored miners.
Bored data miners.
Bored miners or bored miners.
Oh, that could be bored data miners as well.
Talking about bored, I mean, it's bored versus sexy, right? So the interesting aspect of data science. One of the things we notice in our short practice as a software company working with data scientists is they're extremely promiscuous. They keep promiscuous. I call it the promiscuous data scientists. Yes, they're constantly changing jobs, actually, or it seems like they're changing jobs. Is that a feeling or is it real?
Inside the company or from company to company?
From company to company.
Is it a Silicon Valley thing? I mean, are you seeing the same thing?
No, it's across in the last 2 years of our.
I think it's just because the demand for data scientists and people, senior data scientists that have that experience, that have like 5, 10, 15 years of experience, is like there's not that many, because 10 years ago data science wasn't sexy, so there wasn't that many people, right? And then now they're looking for experienced people, so they're in high demand, so they're just like shopping themselves and getting going to the most interesting, highest bidding company.
They know how to apply data science,
right,
for their jobs. Do you see that on LinkedIn, Simon?
Yeah, right now the Bay Area, getting data scientists is hot in demand, so that's one factor of that. Yeah. One of the challenges happen is, let's say given a problem, you build something and it seems to work, and then say, oh yeah, this problem is solved. But there's a little bit of tendency that, oh, this problem is solved, I need to work on the next coolest thing. The part which is missing is that taking this thing which is working for like X number of things to scale it to that part. I think it takes time, and it's a challenge, but we just accept it, I guess. But I think as more and more data science become part of the engineering, I think that's right now. It'll be. Then they will feel that they are part of the product, building the product, not just I'm doing data science. Then I think things will change a little bit.
So for the job change perspective, never done any research or data mining or on this. My overall observation is something like this. In the early stage, when the data science just been defined, let's say 6 years ago, I think so the definition is not very clear. Even right now, right, a lot of articles almost every week, every day talk about what is data science. I think that create a too side of story. One is very demanding, right? A lot of people would like to find a new job, getting better and being more creative. Number two is sometimes if there is a loss of focus, it could create potential attrition or churns, right? It's at the company level or the employee level. That's why I would say the people like to join the party, better understand, so what's this party about, and what's the ultimate value we deliver. And I have a strong belief people stay in the career longer, might generate more value, right? But a lot of young folks. Another thing is observation. A lot of data scientists are young, very young, just graduated from the PhD program, super brilliant, creative. They want to use data to change the world. So, and on the other side, there's a reality, right? To implement something into production, it's hard. It takes a lot of time and effort and expertise. So I would say that to keep certain level of balance and set the right expectation is important for the young data scientists to be successful, and also for all of us. Yeah.
Sure, you've seen your share of your own data science people moving around, but it's probably a factor of the whole space is definitely in a very good, it's one of the best times to be in the space because there's not only a lot of light shined on the space, but a lot of applications, data products are coming out. The way we reason that out is that the whole, as we started, the data science practice was really statisticians and some corner observers, skeptics, to them taking the center stage and trying to define how business should be run. I think this definitive observation that technology and data science are coming together even. And so to Prasanta's point, they're implementing products that are, and so they're moving between technology and data. We're seeing that a lot, actually. I think that kind of, we've run through the gamut of questions. Didn't get into too many fights, but that's probably natural, given data scientists are skeptics. They didn't want to get into any fight. But it's been a pleasure to have hosted you guys. Thank you for staying long and being on the panel, as well as being part of our journey as H2O. And as we call H2O World to an end, I think it's very appropriate to be amongst customers and users of the product and the community that we're going to build ahead. We definitely look forward to your continued camaraderie as we build a phenomenal movement here of data scientists and mathematicians and technologists. So thank you.
Thank you.